Uh, Today we will solve the example 2.1 of Griffith third edition Introduction to Quantum Mechanics. Suppose a particle start out in a linear combination of just two stationary state, that is psi of x and 0 is equal to c1 psi 1 of x and c2 psi 2 of x. To keep things simple, I will assume the constant Cn and the state psi n of x are real. What is the wave function psi of x and t at subsequent time? Find the probability density and describe its motion. So this is the question. Here we have to find psi of x and t and probability density, and we have to describe its motion. So now we take a single wave function, that is psi of x and 0 is c psi. So single stationary state. Then psi of x and t for this single state is c psi e power e power minus I e t over h cross. So what about to modulus square of this wave function? You just take c square. When you take modulus square of this exponential term, it will become e power plus I e t over h cross into e power minus I e t over h cross. So e power minus I theta into e power, uh, I will change it. So uh, e power minus I theta into e power plus I theta is equal to, naturally is equal to 1. So this exponential term will go away. Then we will get only c squared psi squared. So time dependence goes away. So it is called stationary state individually. Remember that it is individually. If you take any one of the wave function, I have dealt with this generalized solution, that is c psi. So I have not mentioned psi 1 or psi 2. This is valid for psi 1 independently and psi 2 independently. When you take linear combination, we will see what will happen. The initial wave function is given in the form of linear combination. That is psi of x0 is equal to c1 psi 1, c2 psi 2. This c1 c2 are the expansion coefficient or probability amplitude, we can take it. So what is the time dependent wave function? That is psi of x and t. I am multiplying this by first term by this is the ground state energy level. So which is equal to e power minus I e1 t over h cross. Similarly here c2 psi 2 e power minus I e2 t over h cross. So if you take psi star, that is complex conjugate of this, since C1, C2 are real as given in the problem, so you take the complex conjugate. This minus I will become plus I. Here also minus I will become plus I. Now you take modulus square of psi square, modulus square of the psi. So which is nothing but psi star psi. So you multiply this and this. So you take first self term, you multiply this and this, these two terms. Then you will get is c1 squared, psi 1 squared. This exponential term will go away. Then you multiply this and this. This will be c squared and psi 2 c2 squared, psi 2 squared, and this exponential term goes away. So now you take the cross term. that is first psi star psi cross term. You take this term and this term. And this you will get C1 psi 1 and C2 psi 2 you can take as a common. That is C1 C2 psi 1 psi 2 as a common term. I have taken that. Then if you multiply this and this, you will get e power minus this minus I am taking minus I e2. This is plus e1. So I will take as minus e1 because I have taken minus outside. So minus of minus will become plus. Now you multiply this and this. Remember that I am taking psi star psi. So you take psi star first and psi next. So here also C1, C2, psi 1, psi 2 is common. That is C1, C2, psi 1, psi 2 is common. Now you take this. Here you have plus e power minus, sorry, e power plus I e2 t over h cross. Here it is minus e1. So I am taking this as I e2 minus e1 t over h cross because e2 is a higher energy level. So now you know the omega is equal to e2 minus e1 over h cross. So I am replacing e2 minus e1 over h cross as omega. So the first term will become e power minus I omega t. Then the next term e power e power plus I omega t. So we know that e power I theta plus e power minus I theta is equal to 2 cos theta. So I am replacing this by 2 cos omega t. Here I have taken 2 and cos omega t. So I have replaced this. Now, what is modulus psi squared? That is probability. Probability is equal to modulus psi squared. Probability density is equal to. So, which is not a time independent. There is a time dependent factor. That factor is time dependent. So, this probability will oscillate. Sinusoidally it will oscillate with respect to time. So if you take linear combination of two stationary state, you will get the time dependent state. So stationary state means is independent of time, but here you can see the probability is time dependent. If you try to find the expectation value of x or x squared, expectation value of x is equal to integral x modulus psi squared, you know very well. Similarly, expectation value of x squared is integral x squared modulus psi squared. So everywhere this sinusoidal term comes. So this motion of the wave packet is the sinusoidal one. It will move sinusoidally with respect to time. So thank you very much for watching my video and supporting me continuously. Thank you very much.